Yeah.
Okay. Well, so the first question, the first thing you need to know is which is latitude and which is longitude, right? So if you're looking at the globe, right, we've got lines that go up and down from the North Pole to the South Pole, right, like this. And we've also got lines that go around, let's say, horizontally, like this, parallel to the equator, right? So which is which, right? Well, the lines that go horizontally, right, parallel to the equator, those are lines of latitude, right? And then latitude increases as you go north. The equator is 0 degrees latitude, and it goes from 0 degrees latitude at the equator to 90 degrees north latitude at the North Pole, and it goes to 90 degrees south latitude at the South Pole, right? So, latitude goes north and south. The lines of latitude go around east-west, right? So, because there are two hemispheres, a northern hemisphere and a southern hemisphere, you need to specify which one you're talking about, right? So if you just say 10 degrees latitude, nobody knows whether you mean 10 degrees north latitude or 10 degrees south latitude. So a complete and unambiguous statement or description of latitude will include the word north or the word south, or you can use N and S in English for those, as abbreviations for north latitude and south latitude, right? Lines of latitude, the ones that run in this direction parallel to the equator, they are called what? Do you know? They're called parallels, right? We have parallels of latitude, right? The way I remember that is that, when I was growing up, it hadn't been all that long since the Korean War. And the Korean War, as you may know, is still not over. There's only an armistice, not a peace treaty. And the line that divides North Korea from South Korea, right, the demilitarized zone, runs along the 38th parallel, right? And if you think about the Korean Peninsula and you think about the division between North Korea and South Korea, right, that line runs approximately east-west. And that's the 38th parallel of latitude, right? So, lines of latitude are parallels, okay? Now, longitude, right, lines of longitude run north-south from the South Pole to the North Pole, right? And so, as you move from east to west, your longitude changes, right? So, one of the best ways of remembering this is that longitude is time, right? As you move east and west, your time changes, right? I'm not talking about in the relativistic sense of like the movie Interstellar or something like that, right? I'm just saying that, as you know, we have time zones, right? So if it's 9 o'clock here in the east, it may be 6 o'clock in California. So longitude corresponds to time. And traditionally, the way sailors have measured longitude is by keeping track of the time, right? And in fact, back in the 18th century, the British government offered an enormous prize for anybody who could build an accurate chronometer because they needed it for navigation, right? So, lines of longitude run north-south, but they change as you go east and west, right? So, with latitude, we have a natural 0 point, which is the equator, right? So the equator is 0 latitude. We don't have a natural, obvious 0 point for longitude. but I'm sure that many of you know where it is, right? 0 longitude is what we call the prime meridian, and it runs through Greenwich, England, right? And specifically, doesn't just happen to run through Greenwich, England. There's a good historical reason. It runs through the Naval Observatory in Greenwich, England, where you can stand astride the prime meridian, right, with one foot in the eastern hemisphere and one foot in the western hemisphere. And of course, the reason that the prime meridian runs through Greenwich, England is because when the system was really developing historically and becoming accepted and being formalized, Britain really controlled the seas. You know, they controlled the seas for a very long time. And they were an important, obviously, colonial power, world power, and mercantile and maritime power. And so a lot of the system of navigation that we use today, you know, dates back to that period and reflects those historical facts. So 0 longitude runs through Greenwich, England, which is just outside of London, right? And lines of longitude that are west of there are west longitude, lines that are east of there are east longitude, and the numbers run from 0 to 180 degrees, right, where the two hemispheres meet way out in the Pacific, right? So latitude runs from 0 at the equator to 90 at each pole, whereas longitude runs from 0 in Greenwich, England to 180 in each direction, right? 180 plus 180 is 360. And of course, the Earth being approximately spherical, we have 360 degrees in the circle, right? What are lines of longitude called? You already have a hint because we referred to the prime meridian, right? Well, we have meridians of longitude, right? And so we have parallels of latitude and meridians of longitude. Longitude runs from 0 to 180, both east and west. So we are in the western, so-called western hemisphere, and you know, we're at, I don't know exactly, our latitude is in the 20s, and our longitude in the 70, 80, something like that, west longitude, and obviously north latitude, right? If you do a lot of archaeology and you use GPSs and GISs, you typically know the latitude and longitude wherever the hell you are. I just don't do much work here, so I'm not that familiar with the numbers. I don't remember the numbers offhand, right? So, we write, latitude and longitude using a system called degrees, minutes, and seconds, right? So you might have 22 degrees, 15 minutes, right? We use the apostrophe for minutes, and 30 seconds of, let's say, north latitude, right? And this is done kind of like time, where the degrees are hours, and then you have minutes and seconds, right? So guess how many seconds there are in a minute? There's 60 seconds in a minute, and guess how many minutes there are in a degree? Again, there are 60, right? So there's 60 minutes in a degree, and there's 60 seconds in a minute. How many seconds are there in a degree? 3,600, which is 60 squared, right? So this is the traditional way of writing latitude and longitude, right? You can have the same kind of, 92 degrees, 45 seconds, 45 minutes, and I don't know, 10 seconds, right? Let's say west longitude, right? So those are sort of natural ways of writing these things. However, computers don't operate well with this kind of notation or with base 60 numbers. I mean, you can program them to do it. You know, computers can do calculations in other bases, but you know, the native format for most programs is base 10 because that's normally what we use for most things. So GISs and to some extent GPSs prefer decimal degrees, right? And I will show you in a second how to convert degrees, minutes, seconds to decimal degrees, okay? Before we go to do that, I want to add something that I forgot to say in so many words at the beginning, right? Latitude and longitude is a spherical coordinate system, meaning that the lines conform to the sphere or spheroid of the Earth. It's not a projection, right? It's sort of a true coordinate system in that if you can specify your precise location in latitude and longitude, that's your position on the globe, right? So it's not, so another way of referring to these are as unprojected coordinates, right? They are not projected. They are also called geographic coordinates, right? So if you're, I don't know, trying to figure out like what your projection is or something like that, if you're using latitude and longitude as recorded, for example, by your GPS, those are your geographic coordinates and they have not been projected. They are actually the coordinates for the surface of the Earth, right? When we project the surface of the Earth onto a two-dimensional map, then, you know, the geographic coordinates become projected and often are converted to some other kind of mathematical system. Every process of projection, however, there are many, many different projections that are used in cartography, which is the science of map making. So there are many different projections that are used. Each one of them has advantages and disadvantages, but the process of projecting from the spherical surface of the Earth to a flat two-dimensional plane always involves some error or distortion, right? It always introduces some error or distortion. Whereas, you know, to the extent that your geographic coordinates in latitude and longitude are correct, those are undistorted, right? There is no distortion due to projection. That's why both GPS and GIS typically, you know, register, record, and remember coordinates in latitude and longitude instead of in some other coordinate system that involves projection. It's because the geographic coordinates, in other words, latitude and longitude, are the most accurate system because it's designed for the spherical shape of the Earth. The lines of latitude and longitude follow the surface of the Earth. They're not peeled off and flattened out, right? So they are relatively undistorted. In the next little video clip, I'm going to show you how to convert from degrees, minutes, and seconds of latitude and longitude to decimal degrees.